Chapter 6, Section 6 is about parallel and perpendicular lines. So by the end of this lesson, you should be able to determine whether lines are parallel and whether or not they are perpendicular. So in this picture here, the blue and purple lines are parallel. Parallel lines exist in the same plane, which kind of means that they're drawn on the same piece of paper, and they never ever cross. Remember that lines go on forever and ever, so the fact that they never cross means that they have something special with them. Non-vertical lines are parallel if they have the same slope and different y-intercepts. So this right here tells us what we need to know. They need to have the same slope and different y-intercepts. And then they have to say this thing here, any two vertical lines are parallel, because remember, vertical lines have an undefined slope. They don't have a slope. So anytime you have two vertical lines, they have to be parallel as well. So the equations y equals 2/3 x plus 1 and y equals 2/3 x minus 3 have the same slope. Both of them are 2/3, and the y-intercepts are different. One's 1 and one's -3. So that would tell us that the graphs of those two equations are parallel. So in order to determine if two lines are parallel, we need to get both lines into slope-intercept form, which remember looks like y equals mx plus b, and then compare the m's. If the two lines are parallel, the slope should be exactly the same. So it asks us, are the graphs of -6x plus 8y equals -24 and y equals 3x minus 7 parallel? So when I look at this, the first thing I notice is that this equation right here is already in y equals mx plus b. The slope of this is 3/4. So I'm looking for the slope of this line and trying to match it up, seeing if it is 3/4. Now, right now it's in standard form. And remember, standard form doesn't tell us the slope. It helps us find the intercepts, but we don't really care about those right now. So what I'm going to do is get this equation in y equals mx plus b form so that I can compare them. So the first thing I got to do is move my x's over. So I get 8y equals 6x minus 24. And then divide everything by 8. So I end up with just y here equals 6/8x, and then -24 over 8 can simplify to -3. Now remember that fractions can be simplified. So this 6/8 right here, we know 6/8, if I divide both by 2, is the same thing as 3/4. So if we look at our slopes, this one's 3/4 and this one's 3/4. So that means that these two lines are parallel because the slopes are both 3/4. So then the other type of problem you're going to get is one that looks like this. And we can use the fact that slopes of parallel lines are the same to write equations of a line parallel to a line that I already give you. So let's say you were given this problem where it said to write an equation for the line that contains this point and is parallel to this line. So remember, in order to create an equation, we need at least 2 points or 2 points or 1 point and a slope. And this right here, this information tells us our slope. So I want something parallel to this line right here. So my new line also has to have a slope equal to 3, because that's that slope there. So then we're going to do what we did yesterday. It needs to go through the point to -6, and it needs to have a slope of 3. So that means we can plug it into point slope form. And remember, point slope form is y minus y1 equals m times x minus x1. So plug in what we know. I have y minus the y in my point, which is -6, equals the slope times x minus the x in my point, which is 2. Then we got to do some simplifying. So this first thing right here, 2 negatives, remember, make a positive. And then I can distribute this 3. So I get 3x minus 6. And then all I have to do is move this 6 to the other side. And I end up with an equation that's y equals 3x minus 12. Now make sure you compare this before you're done with this problem. Remember, we wanted this line to be parallel to the line that they gave us. So I look at this line's slope and this line's slope over here, and they're both 3. So that means they are parallel. So now let's talk about perpendicular lines. In the picture to the right, the blue and red lines are perpendicular. Perpendicular lines exist in the same plane again, so they have to be on the same piece of paper, and they cross at a 90-degree angle. So two lines are perpendicular if the product of their slopes is -1. And remember, product means multiplication. So a vertical and a horizontal line are also perpendicular. So remember, horizontal lines have a slope of 0, but undefined lines, or vertical lines, are undefined. But we know they always cross at a 90-degree angle. So let's say I gave you this equation and this equation. Now if you take a look at the slopes here, the slope of the first one is -1/4, and the slope of the second one is 4. Now they're kind of closely related, but when I multiply them together, I end up with exactly -1. And this relationship here is something special. It's called opposite reciprocals. So opposite reciprocals can sometimes be called negative reciprocals, but all this first word means in both of them is that you change the sign. So one has to be positive, one has to be negative. And remember what the word reciprocal means. It means to flip something over. So 1/4 becomes 4/1. So let's say I start with this fraction, -3/5. Its reciprocal would mean flip it over, so I get 5/3. And then the negative or opposite, whatever word you want to use, means change the sign. So it's going to go from negative to positive. So this 5/3 is the opposite reciprocal of -3/5. And then remember, when we multiply these together, we end up with -15/15, which is -1. So just like the parallel problems, you're going to get problems like this that say write an equation of a line that contains a point and is perpendicular to another line. So this right here just tells us our new slope. So the original slope is 3/4. The slope that's going to be perpendicular, and perpendicular is represented by this upside down T here, the slope that's going to be perpendicular is the opposite reciprocal of that. So remember, flip it over, so you get 4/3, and change the sign. So instead of positive, we want a negative. So this is going to be our new slope. And our line also has to go through this point, 1/8. So again, we're going to use point slope form and plug in what we know. I'm going to write down the form again, because the more we write it down, the better it'll stick in our heads. And plug in the information we're given. So y minus the y in my point, which is 8, equals the new slope, which I need, which is the opposite reciprocal, that -4/3, times x minus the x in my point. And then it becomes simplifying. So I have y minus 8. If I distribute this, I get -4/3 x. Two negatives here make +4/3. And then to get y by itself, all you got to do is add 8 to both sides. So we end up with just y equals -4/3 x. And remember, when you're adding fractions, you got to find a common denominator. So 4/3 plus 8. Remember, I can write 8 as something over 3. It would be 24/3, because that simplifies to 8. So you end up with 28/3. And that's it. This line here is perpendicular to the line they gave us. And just like the parallel ones, we can check it. Take your two slopes, 3/4 from up here and -4/3 from here, and make sure when you multiply them together that it simplifies to -1. And that's it. Can you determine whether lines are parallel or perpendicular? So here's two different problems for you to solve. You're telling me if they're parallel, perpendicular, or neither, and then tell why, or tell how you know. Make sure you write down any questions you have and we can go over them in class. Have a good night.